Hi guys, I know that this is not the face you were expecting, but I'm going to be with you for this lesson. And there is a question on the board for you to try, which was sort of covering the work that you did in your last lesson before we move on today. So give it a go and we will go through the answer when we have everyone here. And hello. And if you're working on this question and you have worries or things that don't make sense, please feel free to ask. Happy to help as you're working through it. If something doesn't make sense, just shout. I'm hoping that silence means that we know what's going on and you're happy with everything and not that you're feeling horribly confused. When you have an answer for X, please feel free to share. You can either tell me or you can put it in the chat. Anything is great. I'm not gonna put the whole answer here because I know we're still waiting for a few people to join, but I'm just gonna give a bit of a helping hand in case anyone is feeling lost. My hints would be to start by finding that angle. That's great. Definitely work on it. I'm not going to go over the whole answer. Don't panic. And just in case anyone's staring at it, it's like, I have no idea where to start. My hint to you would be maybe try find that angle first. Thanks for letting me know. Okay, so those of you who have just joined, I know I'm not your normal teacher. My name's Jennifer Godlinton. My kids call me Miss G. I teach the grade 9s at the moment through Watobe. but I'm going to be taking you for today. So give this question a try, see how it goes. I'll give you a couple of minutes to finish it properly. Make sure that you're writing your statements and your reasons. Don't just write your statements. Work it out as you go. And then when you have an answer, if anyone feels brave, you can talk us through it. Otherwise, I'll help you talk through this and we will get going on today's lesson. And we're going to look at congruency. Now, your teachers told me that you engage a lot and you ask questions and you chat to her. So please don't feel scared to talk to me. I know I'm a new face, but I promise I'm not scary. You can ask me any questions you like. And if you're working and you're confused by something, let me know. If I'm going too fast, let me know. We can make this a fun lesson. But at the moment, just try and work on the question that you're seeing on the board.
Hi, ma'am. Is it safe to say point X and Y are alternating angles because they are corresponding? I mean, they are equal. They look equal, ma'am.
They look equal. That's a dangerous thing, okay? But yes, there are alternate angles here because we've got parallel lines. So this line over here is parallel to this one. So that angle would be the same as that angle because it's creating a Z for us, if that helps.
Okay, thank you, ma'am.
Sure, no problem. These questions will be on geometry. So within the Watobe app, if you go through geometry, straight line geometry, and parallel lines, you would see these types of questions. Okay, I'm going to give you, I think, 2 more minutes. Hopefully that will be enough. So at 5:07, we're going to go through this question. And let's see if anyone ends up getting to the answer that I'm hoping you get to. We'll see. And if anyone's feeling confident with their answer and they want to explain how they got it, please feel free to volunteer. I love hearing your voices and your questions. So anytime you want to share, you're welcome to. Well, that answer gives me a great big smile on my face. Okay, guys, I'm turning off my camera because I need to flip my screen, but I'm still here, so don't panic. I'm right on the other side of your screen. Let's go through this question. So remember, when it comes to geometry questions, there are always different ways to do it. So you must do whichever way feels the easiest for your brain to see. So we'll talk about a couple of different things that you could have done. I think probably the easiest route here would have been to see that you've got two straight lines over here and they create that bow tie. And when we see those two straight lines like that, we can think of vertically opposite angles. So we know that this angle in here is going to be x minus 20. But remember, whenever it's geometry, we always have to say what we're doing. So we would say angle XYZ is equal to x minus 20. And then our reason vertically opposite angles are equal. Okay. All right. So now we know that that's x minus 20. You said y1. Yeah. Okay. Yes. Okay. So as long as in the picture you wrote that as a 1 and then like a 2 and a 3, as long as you wrote the 1 on there, then it's fine. But that's great. That's exactly the same reason. That's beautiful because of vertically opposite. And then angles of a triangle. Excellent. Well done. Okay. So now we have a triangle situation happening here. So we can say x plus 60 plus x minus 20 needs to equal 180 degrees because of sum of angles in a triangle. And let's just simplify this a little bit. 2x plus 40 is 180. I'm going to move that 40 over. So 2x is equal to 180 minus 40, which is 140. And then we're going to divide both sides by 2. And so we see x is equal to 70 degrees. Did anyone do it in a slightly different way and get the same answer? Or you didn't even have to have gotten the same answer? Did anyone sort of approach this in a very different way and start with a completely different angle and would like to go through that method? No takers. Okay. Okay, so this was sort of summing up what you guys did in your last lesson. And we're going to move into our new topic today, which is called congruency. Does anyone need to sit on this picture any longer, or can I move down? Just let me know if you need it any longer. All right. If I'm ever scrolling and you need me to stay somewhere, you're welcome to just put that little hands up emoji next to your name and I'll see it and I'll stop. Okay, so we're going to be talking about congruency today. And can anyone tell me what it means for two shapes to be congruent to each other, or what the word congruency means? It doesn't have to be a perfect definition. Anything you can tell me about congruency, anything at all.
Ma'am, I think congruency is if the three sides of one triangle are equal in length to the three sides of the other triangle. I'm not sure if I'm right, but I know it goes with those special angles for side, angle, side, and right. Is it?
Yeah, right angle. Yeah, no, you're right.
Yeah.
Right angle, hypotenuse side. That's great. Those are the 4 cases of congruency, and those are what we're going to talk about later in the lesson. That's great. And what you said was perfect. So basically, congruency is when we have two shapes or two or more shapes. Let's just say shapes that are identical to each other. So what I mean by that is that they are exactly the same in every single way. So it's okay, David. Thanks for letting me know. Yeah, exactly. So as we have in the chat here, two or more triangles with equal sides and similar shapes. So congruency means that they are identical. They are the same in every way. Okay. And so that means that their sides are the same, and it means that their angles are the same. So basically, like if I picked up one shape, sometimes I have to rotate it a little bit and I put it on top of the other shape, it would fit perfectly. Okay, so let's have a look. For example, like if I just drew this little triangle here, and I said that that was 30 degrees, and I said that that was 60 degrees. That doesn't really look like 60, does it? There we go. Oh, that still doesn't really look like 60. You're going to have to use your imaginations. And I said that this was 60 and that was 30. At the moment, I'm just saying that those two triangles have the same angles as each other. But in order for them to be congruent, they also would have to have the same length sides as each other. So they need to be exactly the same in every single way. And the symbol that we use for congruency are three lines that are horizontal. And an easy way to think of it is it's like an equal sign with just an extra line. And it's because we're saying they're equal to each other. They're the same as each other. So just think of it like an equal sign, and then you're just adding a little line below it. So it's like an equal sign with an extra line. Okay, so they are exactly the same in every single way. Now, the thing we have to be sort of careful about with congruency is when we say that things are congruent, we have to match up the angles that are the same as each other with each other. So I'm going to call this triangle ABC, and I'm going to call this triangle DEF. If I was trying to say that these two triangles were congruent to each other, and I was talking about triangle ABC, I'm saying it's congruent, which angle is the same as angle A in this triangle? Which letter, D, E, or F, is the same as angle A?
F.
Beautiful. Okay, so we'd have to start with F. Then which angle is the same as B?
B.
Yes, E. And so then we would have D. Yeah, nice. Okay, so what we end up having is we have to match the angles that are the same as each other on both of our triangles. And we create this thing called congruency. So this is a congruency statement. We're saying this triangle is congruent to that triangle. And when we write it, we're saying which angles are the same as each other. Does anyone have any questions about that so far? Okay. So what we've got here is we've got some shapes that are congruent to each other. And I would like you, so I'm less worried about the rectangle because that one's nice and easy because they're all sort of the same as each other. I'm going to write a triangle over here and I'm going to say triangle ABC. And I would like you to tell me how I would write the triangle that it is congruent to. What are those three letters going to be? Sure, my congruency sign is not great. There we go. So look at which angle is the same as angle A and find it in the second triangle.
Ma'am, I think the triangle that's the same as angle A is D.
Beautiful. Great. Okay. And then what would be my next one? So what would we write? What's the same as B? E. Good. And then our last one is F.
F.
Beautiful. Okay. So I know that this is like, oh, this is so boring. Why am I doing this? But it's because if we don't get these angles in the right places right in the beginning, when we get to more complicated congruency, it gets a little bit messy. So what we're going to do now is we are going to practice getting that right. So, and you can write your own triangles. You don't have to write them in alphabetical order. But like, for example, I'm going to do this first one for you, and then I'm going to let you do a couple by yourselves and we'll go over them together. If I was looking at these two triangles, I'm going to say, well, triangle ABC is congruent to, and I know A is 33, so that must be F. I can see B is 67, so that's T, and then C is 80, so that's H. Okay, so we're just going to get into the habit of writing this congruency sentence just to make sure we're getting our angles where we need them to get to. If you're looking at B, look for the number of lines. So here you've got 2 lines, which means it's the same as those 2 lines. Okay, so I would like you all to give B and C a try for me. I'm going to try and make it a bit bigger so you can see the angles a bit better. But I would like you to give these 2 a try. And if you would like to share your answers with us, you're welcome to unmute and share, or you can put it in the chat. Either is great, and we'll go through these 2 together afterwards. Okay, do we have any brave volunteer who can give us the answer for B? How could I write the sentence? Anyone who wants to give it a go? No? Ah, there we go. Thank you. Okay, so we have triangle ABC, and you're saying that that is congruent to triangle TPS, and I'm absolutely happy with that. Yes, great. Now, if you didn't write ABC for yours, so let's say you wrote triangle BCA, and so yours looks a little bit different. As long as they're corresponding, that's fine. So wherever the B is, the P needs to be. So then if you had PST, that's also perfect. Okay, cool. Well done. Okay, who would like to give me an answer for C?
Ma'am, can I give it a go?
Yes, I'd love it.
Ma'am, so L is the same as point T,
Good.
and R is the same as point B, and M is the same as point P. I'm not
Oh,
wrong.
goodness. So P, and M. Beautiful. Nice. So triangle LRP is congruent to triangle TBM. Great. So let's just have a look where Nosisa, I'm trying to see where the Q came from. I think you made your R a Q. I think that's what happened there. LRP, TBM. Beautiful. Nice job, guys. Cool. Yeah, okay. That's okay. As long as we know where it came from. That's what matters. All right. So I'm hoping that this makes sense. Do you want to do one more of these, or can we go on to something sort of one step harder than this? Or do you want one more for practice?
Ma'am, can we go on?
Yes.
This is starting to get boring.
That's okay. Okay. So our different cases for congruency. We have a whole bunch of different ones that we have to know. So case number 1 is that all three sides of both triangles are exactly the same as each other. Okay, so if we can prove, for example, here, that side is exactly the same as that side over there, we can see AC is the same as PR and BC is the same as RQ. So we could prove that there are three sides that are the same as each other. And so we could prove that this triangle is congruent to the other one. Okay, so our one case of congruency is side, side, side. That's one of our cases. Second one is side, angle, side. And that's telling me that we can see that there are two sides that are the same as each other. And then we have an included angle. And the important thing about that angle, and the reason we write it as SAS, is that the angle has to be in between the two sides. So here we've got the two sides that are the same as each other. And this angle is wedged in between them like a sandwich. So it's super important that that angle is right in between the two sides that we know. Otherwise, we can't use this reason. Third reason is side, angle, angle. So we have a side that is the same as each other, and then two angles in the triangle that we can see correspond to each other. And it doesn't matter where those angles are. So I could have also, instead of that one, I could have had that angle and that angle. As long as there were two, then it's fine. Right angle hypotenuse side. So that's our last one. And this is the sneaky one. So right angle hypotenuse side. This one is the one that everyone always trips over because they just always forget what it is, or they want to call it side angle side, but the angle is not in between the two sides. So it's not SAS. Okay. And the important thing here is that you've been given a hypotenuse. And remember, a hypotenuse is the longest side of a right angle triangle, or the side that is opposite the right angle, always the side that's opposite it. And then another side. So like here, we've got a side there and a right angle. Okay, so those are our four cases of congruency: side, 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 side angle, side, side angle, angle, and right angle hypotenuse side. So let's have a look at how we can use those. So for example, here, if we were looking at these two triangles, we can see that this side is the same as that side. This side is the same as this side, and we have an included angle. So I can say, cool, that means triangle A, well, let's write it alphabetically. Triangle ABC is congruent to triangle TPM, and my reason for that would be side angle side. So now we have to start giving those reasons over there. So I'm not too stressed about you writing the sentence over here, but I really want you to be able to have the correct reason. So I want you, of the four reasons for these next, let's try and sneak three in at the same time. For these next three questions, I want you to give me which case of congruency is it. So is it going to be side, side, side? Is it going to be side, angle, side? Is it going to be side, angle, angle, or right angle, hypotenuse side for question 1, 2, and 3, or B, C, D. So think about what they would be. When you're happy, put your answers in the chat for me so I know that everyone is on the same page, and then we can keep going. Sure. So the last two cases up here. Have you got them? Okay, so we're going to look at these three sets of triangles, and I want you to tell me what my reason would be for B, what my reason would be for C, what my reason would be for D. And when you're happy, chuck your answers in the chat for me, and then we can see if everyone is on the same page before we start going on to the harder questions. All right, and you're looking at those four different cases up there. So side, 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 side angle, side, side angle, angle, and right angle hypotenuse side. let's have a look. Okay, so we got some answers for D. Okay, so I'm seeing some good things for B. D needs some work. C is looking positive. Ah, there we go. I'm seeing a good answer for D. That's just coming up. Okay, so yes, there we go. For B, we're looking at the three sides that are the same as each other. So our reason for the congruency here would be side, side, side. Our reason here, we've got an angle, another angle, and then a side. And so our reason for this would be side, angle, angle, which I saw lots of people getting. And for the last one, we've got a right angle, we've got our hypotenuse, and we've got a side. And so our reason here would be right angle, hypotenuse, side. Excellent. Okay, I'm going to move on to the next three. Okay, again, your cases of congruency, side, 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 side angle, side, side angle, angle, right angle, hypotenuse, side. Be careful, it could be none. It could be none of them. They could be non-congruent. Just going to throw that out there before we start checking answers in. Just be careful. That's all I'm saying. I can confirm that at least one of these are not congruent.
Ma'am, please scroll down a bit.
Sure. Like,
Thank you, ma'am.
sure. Okay, so for E, I'm seeing answers of SAA. And you're right, there are two angles and there is one side. But the side isn't in the same place as each other. You see how on this one, it's between where our two angles were. But here, it's up where AB is. If it was in the same place, it would be on AC between those two angles over there, and it's not. And so because the side that's been given to us is not corresponding, it's not in the same place, we can't use the reason side angle, angle. And so for this one, we would have to say that they are not congruent because we haven't been given enough information to say that they definitely are congruent. But yes, exactly. We can say that they are similar to each other. Excellent. We could say that they're similar because they have the same angles, but we can't say that they're congruent. Great. Beautiful answer there. Okay, let's have a look at F. Now, F, we've got in this case, we've got a side and then our included angle and another side. But the problem is on this one, we've got the side, the included angle, and then our other side is chilling down here. It's not where it needs to be. We need it to be over here. So again, we have to say here, not congruent. Excellent. Well done. And sometimes things aren't congruent. And so it's important for us to know where they are congruent and when they're not. The most important thing is something called corresponding sides. So they have to be where the other one is. Now in G, it looks complicated, but it's actually not so bad. We can see that they have the same side as each other, and then they've got the same angle. And we've just spoken at the beginning of this lesson about vertically opposite angles. We know that that angle over there is the same as that one because of vertically opposite angles. And so by doing that, we can actually see, well, there's two angles that are the same, and there's one side which is the same. And so our reason here would be side, angle, angle. Okay. I know that they're a bit tricky. They just take a little bit of work, and it's difficult to see which ones are congruent and which ones aren't congruent. But you'll get there. I'm not going to worry about that 100%. Okay. So all of this is taking us to this final place, which is where we land up going in grade 10, which is where we have to actually prove whether things are congruent or not. And we have to write it in a very specific way. And they're very like anything in maths, everything has to be done in specifics. You know how in geometry you have to learn certain reasons and you have to write those same reasons. It's exactly the same with congruency. So we have to do it in a very, very specific way. And so I'm going to talk you through this first one where I'm going to show you a full proof to show why these two triangles are congruent to each other. And then I'm going to let you work through the second one, and I'm going to give you quite a bit of time to try and figure it out and write down all of your steps. And then we'll work through a couple more. We'll see where our time takes us today. Okay. So when you're writing, you don't have to write this part over here. I'm just writing that so you know what we're talking about. We always start with like an introduction. So we say which triangles we're working in. That's what this first part is about. And so I'm working in triangle ABC, and I'm working in triangle, and we want to try and get the angles to be the same as each other like we practiced in the first exercise. So triangle DEC. Those are the two triangles we're working in. That's our first goal. Okay, so first goal is identifying our triangles. And that's what our first exercise of the day was about. Now we have to keep our second exercise, which was our cases of congruency. We have to always keep that in the back of our mind. So let's just keep it in the same order. Side, 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 side angle, side angle, angle, and right angle, hypotenuse side. Those are our 4 different options. Okay. And we need to prove them. So basically we use each one of these 3 reasons. So like here, I'd be proving that 3 sides are the same. This is my reason 1, reason 2, reason 3. Here, I'd be proving 2 sides are the same and an angle is the same. So that's what the goal is over here. So I can see that they've told us that line AC is exactly the same as line CD. And we know that because they've got these little lines here, which tell us that they're equal to each other. So I can say AC is equal to CD. And we didn't have to figure anything out. They just told us that. So our reason for that is given because it's something that they just gave us. Summer, did you have a question?
Oh, no, ma'am.
You sure? Okay.
Yes, ma'am.
Okay. Then for angle A, so that's this angle over here. All right. We can see that this line is parallel to this line. And so we're creating a Z. And I can say that angle A is the same as angle D because of alt angles when AB is parallel to DE. So that would be my second reason. So in my first reason, I found a side. In my second reason, I found an angle. Okay, you don't have to write those, but sometimes it helps because you know what you've got and what you still need. Third reason, BCA. So now we're saying this angle, BCA, so that angle over there would be the same as this angle over here because they are vertically opposite each other. So that would be the same as DCE because vertically opposite angles are equal. Do you see how you're bringing into like all of the knowledge from grade 9 and grade 10 geometry comes into play here? We use it all. And then, so that was another angle. Then we put this all together. We see, okay, well, we found side angle, angle. That's our case of congruency. So I can say triangle ABC is congruent to triangle DEC. And my reason would be side angle, angle. And so at the end of the day, your whole proof would just not have this. This is what it would look like on your page. So you say which triangles you're working in, give your 3 reasons, and then you say they're congruent and you give the case of congruency, which will be one of those 4 that we spoke about. I'm going to keep this on the screen so you can see it as a guide. And the first one I've got here, I've tried to help you a little bit by guiding you on your way through, so it's not completely throwing you in the deep end. I'm just going to write your cases of congruency here again until you feel confident with them. And I would love it if you could give B a try. So I'm going to give you a nice little bit of time to finish it. Let me know once you're done so I don't interrupt you while you're still working. And when you're ready, we can chat.
Excuse me, ma'am, can you please scroll a bit up?
Sure. What are you needing to see further up?
No, ma'am, I need the other letter, like for triangle AF. I don't know what's the other letter. Thank
You
you, ma'am.
meaning like this?
Yes, ma'am. Just like that.
I see.
Thank you,
Oh, I
ma'am.
see what you're saying. Okay. Sorry about that.
Yes, ma'am. Mm.
Okay. And there's no rush. Whenever you're ready, let me know. If someone feels brave, it'll be great if you could talk us through this. I've still scaffolded this one a bit for you. Your next one, there will be a little bit less scaffolding. We'll see how we go. Just remember, if you need help while you're working, let me know if there's something that doesn't make sense. How are we doing? Are we finding 1 and 2 easy and then struggling with the third reason? Where are we at? Nice. I like it. Okay. AB is definitely equal to AG, and our reason for that would be given. We also need to talk about which triangles we're working in. So in triangle ABF and triangle AGF. Okay, cool. I'm happy with those first 2 lines.
Ma'am, what is the third one meant for? Number 3.
Yeah, so it depends on whichever one you can see. So either you need to find an angle that's the same as each other in both triangles, or you need to find another side that's the same in both triangles.
I don't understand.
Okay, so you see how in the first triangle you're working with AGF,
Yes,
and the
ma'am.
second one we're working with this triangle over here. Okay,
Yes, ma'am.
what do you see about AF?
Isn't it the
What's,
same?
yeah, exactly. Why is it the same?
Because, ma'am, the angles are, sorry, ma'am, the sides are equal.
Yeah, it's AF is the same line in both triangles. So it's the same in both triangles. Exactly. So it's called a common side. So it's a tricky one, but all you would have to write there is that it's common. So I'm seeing some good things coming in through the chat here. So GF is definitely equal to BF, and that's because it's been given to us. And then what we were talking about here is that AF is part of both triangles. And because it's part of both triangles, we can say AF is common. And we use that sentence. We say something's common if it's part of both. Or you could say common side AF is equal to AF. Perfect. As long as we have the word common involved, it's fine. And so now we found a side, we found another side, and we found a third side. So then our conclusion, we could say triangle ABF is congruent to triangle AGF because of side, side, side. And when we write this conclusion, you need to make sure that those angles are the same as each other, like we did in that very first exercise. Otherwise, they won't give us the mark. So it's like a silly thing, but it affects us in a big way. It's one of those irritating things with maths. Nice job,
Ma'am,
guys. Yep.
ma'am, does it have to be in order? For example,
Yeah.
okay.
Yeah. Like, so these could be in any order you like. So like, even if you were doing SAS, you could do it as A and then SS. It doesn't matter. But when we have our conclusion, the angles have to be in the right space for each other. The reason they're quite strict about it in grade 9 and grade 10 is because when we revisit this in matric, if they're not in the right order, then the questions that follow don't work. And so they sort of try and get it into your brain earlier. Okay, I told you I was going to just throw you off. After the first one, I helped you out and gave you a bit of scaffolding, and now I'm not helping you at all. So for this one, I've just given you a picture and I'm needing you to write your proof. So you're going to write it all by yourself. So you're going to say which triangles you're talking about. You're going to find 3 reasons that make them either that sides or angles are the same as each other. And then you're going to tell me why they are congruent. And as you start figuring things out, I'd love it if you let me know or you put it in the chat and we can talk through it. I'm trying to make the picture a bit bigger for you. And down here, I'm just going to write out different cases of congruency that you can start looking out for. And remember, if you are struggling or you need help or something just doesn't make sense, I'm just here. Just let me know. So try and remember your steps, identify your triangles, have 3 reasons, write your conclusion, and let's see how this goes. Always start with the ones that have been given to you because that's the easiest way to start. So either angles or sides that have been given to you. When you're feeling good, let me know what your reasons are as you figure them out. Let me know and I'll fill them in. Cool. Can you give me one of your reasons? You can choose any one of the three, anyone that you're feeling confident with.
Okay, ma'am. I said AD is equals to to DC, and then my reason was given.
Yes. Okay. While you're online, tell me your next one.
And then my second one is AB is equals to BC, and the reason was I don't know how I said hypotenuse. I don't know.
Okay. Yeah. So that one, they haven't told us. So they are equal to each other, but they haven't told us they're equal to each other. So we're not allowed to use it as a reason. We only can use sides that are, if they've like shown. So like if there were three lines like that and that, then we could say that they're equal. But because they haven't told us, we're not allowed to.
Ma'am, I also said number 3, I said BD is common.
Beautiful. Okay, so I'm going to make that my reason too. So BD is common. Excellent. So those of you who are feeling stressed with the common line, it means it's part of both. Okay, so yes, in the comments, it definitely is safe to say that they're common. That's cool. Now, we've got 2 reasons so far, and we need our third reason. And they've given us this 90-degree over here. And so what would that make this angle next to it if it's on a straight line?
A right angle.
There you go. So, okay. So yes, D1 equals D2, but not because it hasn't been given to us. We'd have to say, so angle ADB is equal to angle CDB because of angles on a straight line. Because we knew that, yeah.
Excuse me, ma'am. Ma'am, is it fair to say, right? I wrote the same answer you wrote now. It's ADB.
Yeah.
Is equal to CDB, right? Angles on a straight line. And again, I wrote, I'm not sure, but I'm just testing if you can say it's vertically opposite angles. Not sure.
No. Yeah, no, we can't say they're vertically opposite. If I had, thanks for asking though, if I had another line like this, for example, I could say that those 2 dots are equal and those squares were equal, but we can only do vertically opposite when we have some kind of bow tie, and we don't have a bow tie here. Okay. Okay, so we got those 3 reasons. So now let's figure out what we have here. We had a side. Here we also had a side, and here we had an angle, and our angle was in between our 2 sides, which is what we wanted. And so our reason is side angle side. And that would be our proof. Yeah.
For my reason, the conclusion, I said it's right angle hypotenuse side.
Okay, so the reason I think you said that was because you had said that this side here was the same as that side there. And in that case, that was our hypotenuse, right? But the problem is that we don't know that those are the same. So we weren't allowed to use the hypotenuse.
Okay, I see.
And that's why we couldn't use that reason. That's only, yeah. But I understand why you chose it, and it makes sense for what you did. So you should be proud of that. It just, yeah. When is an angle side given? Okay, so an angle side is given if we haven't had to work anything out. So for example, here, if they also had drawn in that that was at 90 degrees, then we would say that it was given. But we had to use our brains and think, well, if this is a straight line, then that must be 90 degrees. So as soon as we have to figure something out, then it hasn't been given to us. Okay. We got time for one more. So let's see how it goes. It's not a bad one, I promise. We'll stop with this one. So this will be the last one we do tonight. I'm just gonna get the setting out over here. So in triangle RTS and triangle QTP, and then I want my 3 reasons. Therefore, triangle RTS is congruent to triangle QTP, and I want that reason. Okay. You will be absolutely fine. I know you can get 100% for this. Okay, who's starting to feel brave? You can give me some of our first reasons. Let's write them in. You only need to give me one at a time. Who can give me anything that they can see? Yeah.
Ma'am, I said PT is equals to ST. Reason is given.
Yes.
And then I said QT is equals to RT. The reason was given to.
Yes. Yes.
Am I right, ma'am?
You are 100% right. Beautiful.
Okay, ma'am.
Now I need one more. Just take
Yes,
it home
ma'am.
now.
And then I said, I said RTS
Yes.
is equals to PTQ.
Yes.
And then the reason is vertical opposite angles.
Woohoo! You should do a big dance right now. That is 100% correct. Okay. If anyone else got that, I hope that you are just super excited right now. Okay. We have 2 sides that are the same as each other. We have the same angles as each other. So now last little bit, why are these 2 triangles congruent? What's my reason?
They congruent because it's side angle. It's side angle.
Oh, so close.
Am I right, ma'am?
Ma'am, is it fair to say it's side angle side?
It's side angle side. You are so close.
Oh, sorry.
No, don't apologize. You did really, really well there. Okay, so in this case, I'm saying well done. Okay, I'm seeing that someone said, is T a common side? T isn't a common side because it's not. It's it's like a point between the two triangles, but it's not a line that's part of both triangles. So we can't call it a common side. So our full proof is absolutely there. We have two sides that are the same. We have an angle that is the same. And so we can say that they are congruent because of side angle side. Well done, guys. You've done a lot of work today. You should be very proud of yourselves, especially for Thursday afternoon. And that is where we are going to stop. And I'm going to hand you over to Tula.
Hello, great tens. A familiar face once again. So there isn't much from my side today. I'm just gonna quickly share my screen. In the meantime, as always, while I'm sharing my screen, you can tell us how you're doing, how you're feeling, if there's anything you want to share, an update from school, how you're doing. Maybe you got results this week, maybe you have an exam, a test coming up. You can share that always on the chat and we can talk about it. But I'm gonna share my screen and just take a moment. And of course, remember, if you maybe did not have enough time to copy the things that are on the screen before I removed it, you can always go to watobe.co.za, go to grade 10, go to live lessons, and then you can always find these lessons, even previous ones, and you can be able to see everything that's on the screen. So this was our fourth lesson on geometry, and we were proving that our quadrilaterals are parallelograms. And then so we'll be doing next week, we'll be moving on to midpoint theorem, and then we'll also be doing exam type questions. So we're only left with literally 2 lessons for this, just 1 week, on Tuesday and Thursday, and then we'll be moving on to a different topic. Of course, unfortunately, we do not have the leaderboard. We do not have the leaderboard for this particular subject because we do not have this lesson on the Watobe app, but that's all good. We try to cover as much as we can in the lesson so that you still covered as far as that is concerned. But we'll be continuing with the leaderboard and the homework after next week, so no need to worry about that. Let me stop sharing now. Does anyone have any questions? Anyone have anything that they want to ask or want to comment on before I let you guys go? David is saying no, like he just wants to leave. It's just done for the day.
It's all right, it's late in the week.
It is very late in the week and the day. We'll see you guys on Tuesday. Enjoy the rest of your week. Enjoy your weekend. Do some maths and have fun. Bye, everyone.
Bye, guys.
Bye. Enjoy the rest of your week too.
You too, Samu. Bye.
Bye.
Bye, David.